Hey, mathematicians, let me move my picture up here so it's looking like I'm actually looking at you. So this is page 26 from assignment number 2. What should we do with the remainder? I'm going to do page 26 in one video and then page 27 in the next video. For each problem below, use numbers, words, or labeled sketches to solve the problem. Figure out the best way to handle the remainder for that situation and write an equation to show each problem and the answer. So for each of these, I think I'm going to do a ratio table for the first one. I want to show, because I want to talk about ratio tables again and how we can do that with division. And then with the B and C, I am going to do the hangman strategies. And I'm not doing the arrays on these because I don't have the pieces with me, but we've talked a lot about arrays already. So I wanted to show you the other two. We have three different strategies to solve division problems. We have the array model, which we talked a lot about earlier. We have our ratio table, which we've talked about earlier from last week. And we also have the hangman strategy, which is more like your traditional standard solving division problem. It's not quite long division, the hangman strategy, but it's close and it gets us close to that, which is what we will be expected to do by the end of the year. So each of these problems, just like in the first assignment, are dealing with the same numbers, but we have to figure out what to do with the remainders. So let's look at number one. It says 4 friends made 55 cupcakes and shared them equally. Okay, how many cupcakes did each friend get? Pretty straightforward. Let's do this with a ratio table. So basically, it's asking us what is 55 divided by 4? We have 55 cupcakes. We're dividing that by 4 friends. That's our expression. Here's how I'm going to solve that using the ratio table. So what I want to do is figure out what am I comparing first. So remember, my ratio table goes across, and I am comparing friends to cupcakes. So how many friends and how many cupcakes? So if I want to split. So the main goal for this, for the division ratio table, is I have to figure out, I have to get my cupcake number as close to 55 as I can. And that will tell me how many cupcakes my friends will get, each friend will get. So this isn't like how many friends there are. We already know there's 4. This is how many cupcakes will each friend get. This is the total number of cupcakes. This is how many cupcakes each friend will get. Okay. So right now, if I am looking at just my unit rate, we always start with our unit rate of 1 to 4. With division, I'm trying to get my cupcakes up to 55. The magic number is 55, or as close as we can get to 55 without going over. So right now, 4 cupcakes, each friend would get 1 cupcake, right? Because there's 4 cupcakes, and if I gave 1 cupcake to each friend would get 1 cupcake. So that's what this means. Each friend gets 1 cupcake. So if I have 8 cupcakes, each friend gets 2 cupcakes. Let's just keep counting up real quick. If I have 12 cupcakes, each friend gets 3 cupcakes. Let's keep moving. I like this. If I have 16 cupcakes, each friend will get 4 cupcakes. So a total of 16, each friend will get 4. Now I'm going to go to 5 cupcakes. Each friend will get 20 cupcakes. Each friend will get 5 cupcakes. And so now I can mess around a little bit. So I'm at 20 cupcakes right now. Magic number is 55. So I'm just going to jump. I'm not going to keep counting up because that defeats the purpose of a ratio table. But it does help if you count up. I like to do 1 through 5, and then I start messing around with the ratio table a little bit. And what's nice about ratio tables is you can do it however you want. This is Mr. McIntosh's suggestion, though. So right now I counted up by 1 each time. And each time I counted up by 1, I counted up by 4 cupcakes, right? Total. So Each friend right now is up to 5 cupcakes. I'm going to jump up because I notice I'm only at 20 and I don't want to keep counting up. That would take too long. So I'm going to jump up to 40. I'm doubling it. Let's go for it. So if I double to 40 cupcakes, I have to double the top as well. So I have to double the 5. And if I double the bottom, whatever you do the bottom, you have to do the top. So now I'm up to 40 cupcakes and each friend gets 10 cupcakes. So we need to get to 55. So we're close. We're getting there. So now I'm going to go back and look at the rest of the ratio table and see what I can do here. So I notice to get to 55, let's see, what if I add 40 and 20? What if I want to go up to 60 cupcakes? Oh, that's too many. So I can't add these two columns because that would give me too many cupcakes. I don't have 60. But what if I added this column 40 and this column of 16? 40 plus 16. What is 40 plus 16? Well, that is, I'm doing a little math right here, 56. Oh, that's one too many. I don't have 56. I only have 55. I can't just create an extra cupcake. I wish I could. So I can't go to 40 plus 16, which is this column and this column, which was 10 plus 4. So that's 14 cupcakes. That's too many. So what I'm noticing, since 56 is so close to 55, that I am going to go down to 40 plus 12. So I'm going to do 40 plus 12, which is 52. I'm going to use the same columns I used for the 40, which is 10 up top, and 12, so 40 and 12, which is 3 up top. So since I added 40 plus 12, I'm going to add the same numbers within the same columns there. So 10 plus 3, so 13. So each kiddo would get 13 cupcakes. But I notice I'm only up to 52 cupcakes, and right now I have 55, so I have some leftovers. So 55 minus 52 is 3. I am left with 3 cupcakes. So 55 divided by 4. Now I'm turning this expression into an equation because it has an answer. 55 divided by 4 is 13 with the remainder of, sorry, that keeps getting blurry, with the remainder of 3. What am I going to do with those 3 cupcakes? I have to split them up. I don't want to leave them. So I'm going to show you the picture here. So I have 3 cupcakes, and I want to split them evenly with the 4 friends. So I'm going to split these into fourths. Okay. And now I'm going to try to spread these out evenly. So now they're into fourths. So I'm going to label these evenly by the 4 friends. So I know that each friend would get 3 pieces of the total left. So A, Abigail would get 3 pieces. B for Ben would get 3 pieces. C, 1, 2, 3. Clarissa would get 3 pieces, and D, Daryl would get 3 pieces of the total. So really, each person would get 3 out of 4, 3/4 of another brownie, of another total. So like Daryl over here, he's getting 1, 2, 3/4, 3 pieces out of this whole brownie here. Clarissa is also getting 3, even though she's sharing part of this brownie over here. She's still getting 3/4 of a total brownie. So really, 13 with the remainder of 3 is 13 3/4 brownies. Okay. All right, so now we're going to do the hangman strategy on this one. So there are 55 kids in the after school club tomorrow. They are going to the zoo. If each car can carry 4 kids, how many cars will they need to get to the zoo? So let's do the hangman strategy. So I'm going to write out the expression again. So I have 55 kids divided by 4 people per car. How many cars do I need? Okay. So the hangman strategy, we call it the hangman strategy because it looks like hangman, doesn't it? Doesn't that look like the hangman? So the dividend, the number we're dividing by, goes inside the box. The divisor goes on the outside. So the number of cars the people can hold in the cars is on the outside. So now it's just a guess and check. So we're dwindling that 55 number down until we're left with 0 with no remainder, or something that's less than 4 to give us a remainder. And then we have to figure out what to do with that remainder. We did the same problem up here. We know what the remainder is going to be, but I want to show you how that works. So I'm going to guess 4 can go into 55. I'm going to say 10 times. Okay. So right now, I have 10 cars. 4 kids can fit in each car. That means there are 40 kids that have been taken away by car. So I'm going to take that away from our total of 55. And that gives me left with 15. Okay. So right now, 10 cars pulled up. I know that 4 people can fit in each car. So 40 kids were taken away from the total of 55. Now I have 15 kids standing there staring at the teachers at the after school club, like, what do we do? So now we need to order some more cars, get some more cars here. So I know that 4 can fit into 15 3 times without going over. If I did 4, that would be too many because that's 16. But I know I can fit 3 more cars and I can get 12 more kids out of there. So right now I have 15 kids. I ordered 3 more cars. That means 3 times 4 is 12. So I'm going to take that away from the 15, and that leaves me with 3 extra kids. So when I total these up here, that gives me 13 cars right now, 13 cars, but with 3 remaining kids. And we cannot leave those children at, let me move this up a little. We can't leave those kiddos there. So we have to, what do you think? So we have those 3 remaining kids. We have 13 cars. Well, we're going to have to order another car for these kids. Even though they won't fill up all the seats, all 4 of the seats, we still need to get them to the zoo. That's where we're going, the zoo. So really, it's the same thing, 15 with a remainder of 3. But in this case, we need to order 14 cars so we can accommodate the 3 extra kids. Same answer, 13 with a remainder of 3, but a different scenario. So the first one was 13 and 3/4 brownies. Second one, B, is 14 cars. And then the last one, Emma and her friends, so that's 4 people total, did chores for Emma's dad on Saturday. They earned $55 and they split it evenly. How much money did each of the 4 children get? It's the same thing here. So I'm just going to do my hangman again. And the expression is 55 divided by 4, $55 divided by 4 kids. I'm going to guess $10. I'm going to go through this one really fast because I did it up top already. 12. So $13 with the remaining $3. So it's the exact same thing as the first one. We don't want that $3 we have to split between the 4 kids. So if I have $3 and I want to split that between the 4 kids, so I'm going to split each dollar into fourths. Now I need to figure out how much money each of those kids will get. Well, I know that if I split $1 into fourths, 1/4 of $1 equals 25 cents. 1/4 of $1. We split, they're called a quarter because a quarter equals 1/4 of $1. And each dollar is worth 25 cents, or each quarter of $1, is worth 25 cents. So then, if I know that each quarter of $1 is worth 25 cents, it's the same as the brownie question up above, except for now it's money, right? So I'm going to Emma, I'm going to do the same thing I did before. So Emma, I'm going to put with an E, will get these 3/4. Okay. Brenda, her friend, with the B, will get this quarter here and these 2 quarters here. So she'll also get 3/4. And then Carrie with a C will get 1, 2, 3/4. And then Diane with a D will get 1, 2, 3/4 as well. So 3/4 is 25 cents plus 50 cents plus another 25 is 75 cents. So instead of 13 and 3/4, we write that as each kid will get $13.75. You could also say $13.75, but when we talk about money, 3/4 of a dollar, 3/4 of a dollar equals, I'm going to put it as change, 75 cents. Okay, so it's the same answer as the brownie one up above, 13 and 3/4, but we do $13.75 because 75 cents is 3/4 of a dollar. Remember to pause, stop it as you need to, go through this page with Mr. Mack if you need to. And I hope that helped, and good luck. Now, next we will talk about page 27. Okay. There's my last video. Check it out. Can we stop this? There we go.